out over the past 25 years. Some of those efforts deserve special attention. We have educated more than 7,000 healthcare students throughout our medical education programs. Our survivors, volunteers, share their personal experiences at colleges and universities throughout Minnesota to help ensure women are diagnosed promptly and referred appropriately. We've also awarded more than $530,000 to survivors to help make their dreams come true. This is all possible thanks to the special funding designated for our MOCA Dream Awards program. MOCA is definitely here for our community. We provide meaningful connection opportunities for our survivors, loved ones, and caregivers. MOCA offers several support opportunities, including 3 monthly support groups, a walking group, our MOCA Mentor Program, MOCA Cares Kits, and educational meetings, and more. MOCA does so much to provide hope for our community. Research is at the heart of our mission. We're focused on accelerating the pace of ovarian cancer research to find more effective treatments and early detection tests. Tonight, I'm excited to share that we'll be awarding 5 MOCA Research Awards to innovative Minnesota-based ovarian cancer research projects. We know our work is only possible because of the incredible support of our survivors, families, healthcare providers, researchers, and friends. Thank you all for being here as we continue to light the way and provide hope to our survivors and loved ones. Now it's time to give special thanks to our MOCA's Board of Directors. Our board is comprised of ovarian cancer survivors like me and family members and our wonderful dedicated ambassadors for our organization. If you are a past or present MOCA board member, please stand up and be recognized. Thank you to all of our past and present MOCA board members for your service and commitment to MOCA. This year, we have one incoming MOCA board member to introduce or reintroduce. Christine Greer served on the MOCA board of directors for 6 years and 5 years as MOCA board chair. She stepped down last year due to term limits. Since then, Chris has stayed active and involved with MOCA as the chair of our Light Duluth Teal Gala, lead volunteer for our Trees of Hope campaign in Duluth, and as our spokesperson for MOCA. Thanks there. As a 23-year cancer survivor, Ovarian, Chris is also volunteered for MOCA's Survivors Teaching Students program and a MOCA mentor. You can see how passionate Chris is about MOCA and our mission, and we are so excited to welcome her back to the MOCA board. Chris, will you join me up here? You recognize? Thank you, Chris. We are happy you'll be joining us back on the MOCA board. You have inspired so many others to support MOCA's mission, volunteer, and get involved throughout the year. We're already preparing for our big events coming up during Ovarian Cancer Awareness Month in September. I'd like to invite you all to the Home Teal Strides for Ovarian Cancer, Saturday, September 7th at Roslyn Park in Edina. This year, we'll celebrate 25 years of impact at this fun and inspirational event. Join us to walk, run, or bring your family and friends for this fun and this inspirational morning. You can sign up as a team or an individual and fundraise at mnovarian.org. We're also making plans for MOCA's annual Light Duluth Teal Gala, Saturday, September 28th in Duluth. Yeah, September. Lots going on. Spend the fall weekend in the Northland enjoying the beautiful scenery and all the fun at our gala. This event includes a cocktail reception, silent and live auctions, dinner, a program, games, music, and more. You'll also want to check out all the Duluth area landmarks lit in teal to celebrate this special event. Registration details are coming soon on our website, and remember the funds raised at these events have a direct impact on the amount of Research MOCA awards each year. So please consider joining us at both of these events in September. Now I'd like to share about a meaningful way that you can help MOCA continue to fund vital research projects in the years to come. On your tables, you'll find information about joining MOCA's Forever Teal's Circle Legacy Giving Program. When you give a legacy gift to MOCA, you make a lasting contribution. So I'd like to invite you to consider including MOCA in your estate planning and making a special gift to ensure more progress in the years ahead. If you are interested in joining our Forever Teal Circle, please reach out to MOCA Executive Director Kathleen Gavin, or you can call the MOCA office as well. So before we get to our research award presentation, I have one final note. Please fill out the evaluation forms on your tables to tell us your thoughts about tonight's events. Now it's time to turn our attention to MOCA's new research. So I'd like to invite Kathleen Gavin to the podium now. MOCA has been fortunate to have Kathleen serve as Executive Director for 22 years now. We are grateful for her leadership of MOCA and her outstanding contributions to the ovarian cancer research community here in Minnesota and across the U.S. Let's welcome Kathleen with a round of applause.
Thanks, Carol. We're so grateful for your service and leadership as MOCA's board chair. In addition to chairing the MOCA board and her executive duties, Carol's always willing to lend a hand for MOCA, whether it's taking photos at MOCA's events, helping out with our website, featured in a commercial, which you may have seen for First Bank and Trust. Carol's always willing to step up and help out. Thanks for all you do. And I'm super excited to have Chris Greer back on our board. It barely missed a beat. She's been involved, but happy to have her officially back on the board. She's a true champion for our mission, and we're so grateful to have her as part of our organization. I do want to thank every single one of our MOCA board members. They're an incredibly dedicated group of people committed to our mission. We have a wonderful community supporting us, and they lead the way. We're grateful to all of our survivors, supporters, healthcare providers, researchers, and guests with us here this evening. Because of your support, MOCA is lighting the way for new research advancements. If you can't hear me in the back, will you let me know? Pam, you can hear? Thanks, Doug. We've come a long way since MOCA was founded in 1999. MOCA began first when a few survivors gathered together to support each other. And they had the foresight to look beyond themselves and their own struggles and look towards the future. They knew that research would change the course of this disease. MOCA raised $91,000 at our first walk-run event. Back then it was called Silent No More, as somebody reminded me. And we awarded our first 2 ovarian cancer research grants with these funds in 2001. Tonight, I'm proud to share that MOCA will exceed a new milestone of a total of $12 million awarded for ovarian cancer. It's a lot. It's quite an accomplishment for a statewide organization. MOCA's commitment to research funding is recognized across the nation, and we're proud of this achievement. It's not every ovarian cancer organization that supports research. In fact, there's very few local or state groups that do. So again, it was the foresight of our founders who said, you know what, a lot of this should go to research. So tonight we're going to be awarding an additional $500,000 in new ovarian cancer research grants to 5 Minnesota-based researchers. We've been amazed by the quality of innovative ovarian cancer research projects happening in labs right here in Minnesota at the University of Minnesota and Mayo. MOCA continues to fund projects aimed at finding more effective treatments and one day a cure. MOCA is also focused on finding an early detection test. We need a reliable strategy to detect ovarian cancer in its earliest stages, and we're inspired by the progress being made at institutions across the U.S. to make this test a reality. MOCA has committed an additional $100,000 for our National Early Detection Research Awards this year. We'll be presenting these awards in November at our annual award celebration. With this amount, MOCA will be awarding a total of $600,000 to ovarian cancer research in this year alone. Over the years, MOCA-funded research has led to new clinical trials and the development of several innovative approaches, some using immunotherapy and vaccines to prevent recurrence and treat progressive disease. MOCA's research has also led to advancements in early detection tests and a better understanding of how ovarian cancer starts and progresses. Our funding has enabled Minnesota-based researchers to expand their work and receive multi-million-dollar federal grants. MOCA is advancing research in ways our founders could only dream about 25 years ago. We also collaborate with partner organizations to accelerate developments in the field. Since 2020, MOCA has partnered with Any Mountain, a nonprofit organization raising awareness and support for the prevention and early detection of ovarian cancer. MOCA is distributing $300,000 raised by the Any Mountain Mount Everest Trek team to cancer centers throughout the U.S. for the expansion of the WISP-2 trial. This is a surgical prevention trial that is open across the country, and in 2023, MOCA funded the expansion of the trial to Mayo Clinic in Rochester, University of Washington in Seattle, Memorial Sloan Kettering in New York, and Dana-Farber in Boston. Our collaboration with this project is making a difference for women right here in our own state and across the U.S. And the ultimate goal is to prevent ovarian cancer in women who are at high risk. Working together, we are making history and lighting the way for progress. Women diagnosed with ovarian cancer today are living longer, better quality lives because of research advancements. We've seen survivors benefit from targeted therapies, combination therapies, precision medicine, PARP inhibitors, and more. The development of, and more recently, the development of new drugs called antibody-drug conjugates, ADCs. One of those drugs, Elahere, is available today, and others are in the pipeline. Until we find a cure, we know there's more work to be done. We're so grateful to our donors for supporting these research efforts. I'd like you to know that MOCA takes your contributions very seriously. We are highly rated among leading charity watchdog groups. Charity Navigator gave MOCA an exceptional 99% ranking, which very, very few organizations across the country receive. Of course, I wanted to know why we didn't get 100. I'm going to go after that other 1%. We work hard to ensure that every dollar awarded for research grants goes directly to advance ovarian cancer research projects. Our awards are not gifts to institutions. They are awards for specific projects that are rigorously reviewed during a competitive grant-making process. Our projects are reviewed by a team of national scientific reviewers made up of scientists, MDs, and PhDs from across the country, all highly regarded in their fields. These reviewers make sure our projects are well designed and of national significance. It's a little bit of a changing cast of characters, but there is also some that return every year. It's a big lift to ask people to review these grants, and they do it all in service to MOCA and in service to the field. MOCA's projects are also reviewed by those impacted by ovarian cancer. Our consumer research reviewers represent survivors and loved ones, and they help us select projects that are most likely to benefit our community. We're so grateful for the time and effort spent by our consumer and scientific review teams. They spend hours delving into the details of each project. I'd like to thank these teams for their efforts helping us select our 2024 MOCA research grants. 2 of our consumer research reviewers are here with us tonight and will be joining me to help present some of the awards in just a few minutes. Now I'd like to announce our first award of the evening. The first MOCA award will be to Dr. Bo Weber for a project entitled Gene-Edited Tumor Infiltrating Lymphocytes, known as TILs, or Ovarian Cancer Immunotherapy. Now, this project is a little bit different. This funding, sometimes MOCA gives money for new concepts to help somebody develop just the kernel of an idea. This is not a totally new concept. This builds upon a clinically active, cutting-edge approach to genetically engineered cell therapy. And if it sounds expensive, it is. There has already been much investment in this immune-based cell therapy to treat advanced ovarian cancer, including a MOCA award in 2021. The grantees made tremendous progress with the previous MOCA support. Our funding will help a complicated and expensive project overcome some of the challenges of being adopted. This award will be used to simplify the most complex and time-consuming aspect of TIL therapy, and that is neoantigen selection. The researchers in MOCA hope that the findings of these studies will allow them to make significant progress developing and validating the use of genetically modified TILs for the treatment of ovarian cancer. Please join me in welcoming Dr. Bo Weber, Associate Professor at the University of Minnesota.
Thank you very much for that introduction. It's truly an honor to be here and to hear about the impact that MOCA has had over the years. The backstory is really, truly incredible. As Kathleen said, the project that we're working on utilizes gene-edited TIL for cancer immunotherapy, specifically, in this case, for ovarian cancer therapy. But I'd like to say that using TIL for therapy is not a new concept. It's part of what is referred to as adoptive cell therapy. So this is taking T cells out of a patient's own tumor, growing them up in large numbers, essentially reinfusing them back in the patient to target the cancer. Now, pretty much all cancers have TIL within them, or tumors within TIL within them, but they're fighting a losing battle, and taking them out and growing them to large numbers sort of generates an army that's enough to kind of overcome the suppressive effects of the tumor microenvironment. And this has worked for cancers like melanoma and lung, where there's a high amount of mutations, and these mutations are what these T cells are able to recognize in the patient. And so in order to go after cancers with fewer mutations relatively, you have to use this really complicated process to select small populations of T cells that are reactive to the patient's tumor, and then grow them up and reinfuse them. And this is actually, even though it's complicated and costly, has resulted in really incredible, durable, complete responses in solid tumor cancers, advanced metastatic disease. And most of this has been pioneered by Steve Rosenberg at the NCI, as well as others now. But the problem is that, in addition to the complexity, the tumor microenvironment is highly suppressive, highly complicated. I won't get into details, but there's a lot of things holding these T cells back from doing their job. And so in collaboration with the Rosenberg group and the NCI, this a number of years ago, our group identified a gene called CISH inside T cells. And this is a checkpoint, but it's not a checkpoint on the outside of the cell, it's on the inside. And so that's why we turn to using genetic engineering with CRISPR technology to knock out this CISH gene. And if you just kind of look at this diagram here, essentially a T cell has to kind of reach an activation threshold before it decides to start killing a tumor cell. And in a tumor microenvironment, this is a very high hurdle. When we knock out CISH, we essentially reduce this threshold, and these T cells are much more able to target and kill these cancer cells. We were able to initially translate this to the clinic in collaboration with Emil Liu and others at the UM for metastatic GI cancer. We've treated 12 patients over the past 3 years with a really good safety profile and actually some really interesting responses. It's ongoing, so I'm not going to talk about it now. But this really set the stage for potential applications in other cancers, because now we have the pipeline assembled, and in collaboration with a friend of mine and a really close colleague now retired, Tim Starr, In 2021, we received a MOCA award to start to develop proof of concept that we can use these engineered TIL for ovarian cancer. And we actually ran a process development. Essentially, I won't go into details here, but we showed that we could take an ovarian tumor, we could grow out TIL, we could find the number of TIL that react to the patient's tumor, we could grow them up to large numbers and knock out CISH, and essentially the whole process for clinical scale production works. And we need a proof of concept to make this simpler and easier. Because the whole process is about takes about 100 days to do this from when a patient's tumor is resected, which is, for as remarkable as this can be, is a long time for patients with advanced cancer to wait. And so, with the support from MOCA and our initial award, we've made tremendous progress in shortening this down to about 30 days, utilizing some compounds that enhance the growth of these TIL and also enhance their function. With the current award, what we'll be doing is working on a way to obviate the need to select all these little fragments of tumor and select the neoantigen reactive TIL based on markers on the outside of them. This makes it much more simple and much more rapid and cost effective to produce these TIL. And we'll combine this with our enhancers, the gene editing, and carry out a number of functional studies to characterize these TIL and identify a process that's highly effective. And at this point, we'll be at a point where the application to get this into the clinic will be in a much better position from a cost standpoint to be able to run such a complex clinical trial. I will note that we also have established a really good collaboration with Mayo, Scott Kaufman, and also Dr. Matt Block here as well to receive samples. And so with that I'll end. This is obviously, it's not just me, it's a huge team to do these whole clinical enterprises. But I'd like to call out a few collaborators, so especially the TIL Lab and my collaborators at the U of M who made this all possible. And obviously, once again, thank MOCA for the generous support.
Thank you. Dr. Shenyan Wu from the Mayo Clinic will be receiving an award of $100,000 for his project titled Investigating Soluble AXL as a Biomarker in Ovarian Cancer, Implications for Prognosis and Treatment. This study builds upon Dr. Wu's prior research funded by MOCA in 2019, developing an antibody-based therapy targeting AXL receptor tyrosine kinase for ovarian cancer. This research seeks to establish AXL as a diagnostic and prognostic marker and a companion diagnostic tool. Here to tell us more is Dr. Wu.
Thank you again, MOCA, to give me the opportunity to continue my research, because I received this in 2019. Actually, MOCA is very, very important to my program, and I moved to Mayo Clinic in 2019 from Johns Hopkins University, and this is the first grant I received after I joined the Mayo Clinic. So as just mentioned, we are trying to study receptorizing kinase called AXL, and to understand its oncogenic role in cancers. We initially, when I was at Hopkins, we started this program around 2012. I think it's almost 12 years. We initially focused on breast cancer. So because it is receptorizing kinase, and it's a very important oncogene, and it's overexpressed in many different cancers. And as I show the cartoon here, receptorizing kinase is basically it's a protein which span the cellular membrane, so it can feel the signals from outside and translate the signals into the cells, make tumor cells grow faster, more invasive, become metastasis. And so we initially identified this protein in breast cancer. And one of the reasons we study is because it has very fancy name, instead of axle, it's also called UFO. So it's interesting to look at protein called UFO. So yes. So after I moved to Mayo Clinic with the support from MOCA and also ovarian cancer spore at Mayo, we find axle is also very important for ovarian cancer. Basically, from the curves, surviving curves from the right side, you can see the patient, if has axle expression, has much worse prognosis compared to the patient without expression of axle, which is the point, the red line, which has the much worse prognosis, compared to the tumors without axle. So then we developed a receptor, we developed an antibody which can target the extracellular, the outside of the protein of the cell, which can recognize the protein and I think the mouse, if I can show this clip, is it possible? Oh no, okay, I'm sorry. So yeah, this is actually this is a video clip, which you can see the axle is on the membrane of the cells. So if we treat this cells with our antibody, it will quickly internalize and degrade it. It's a video, you can see it can be degraded within like 40 minutes. So unfortunately, I cannot show it here. But anyway, so and with this antibody, we can also show you like it's dramatically slow down the tumor growth in vitro, in mouse models. And also, after MOCA support, then in 2023, we got a DoD grant from the Ovarian research program from DoD. And with our research going on, we're actually using mass spec to find that this axle protein, the extracellular membrane of this protein can be cleaved. So it can release from cells. And then we are saying, oh, maybe we can use this as a non-invasive marker because patients with axle expression, they tend to have much worse prognosis. And if we can detect this axle in a bloodstream, so we can have early prediction of the cancer progress, and also maybe we can select the patients if we have, because this is a translational study, we have the antibody to target this axle part of ovarian cancers, so we can select patients at earliest time. So then we actually developed a method that can detect axle at very, very low level at 32 picogram around, and we have validated in the cell lines. It is true we can detect in the cells, they can shed the protein into the cell culture medium, and we also can detect in the normal plasma from the normal controls at a very low level. And now we are going to, this MOCA supported research, we are going to validate, try to measure the concentration of this protein in the patient plasmas. And at Mayo Clinic, because we have a very good collection of patient samples, and with all the paper and pathological record, we are using the same paired samples with TMA we detected from the axle expression differential from the good prognosis, bad prognosis patients, and we use a paired plasma to do that study, so we can correlate both studies together and try to increase our anesthetic power. So the last slide I want to show how important MOCA is important for my research and my group. I joined Mayo in 2018. I received the MOCA first grant from MOCA to support this research. And in 2022, I got another Mayo MOCA supported to study PARP inhibitor resistance. And in 2023, we got DoD grant because MOCA support allows us to do some preliminary data. And in 2024, I received this one to help us to explore more. And again, I want to, we have started to run for the MOCA event at Rochester. It's become a must-do yearly event for us. And you can see my group started growing. In 23, we have more people, and we are growing. Thank you for MOCA.
Thank you, Dr. Wu. Dr. Tim Griffin
from the University of Minnesota will be receiving an award of $100,000. Unfortunately, he's not able to join us this evening. However, his senior lab member, Dr. Pratik Jatab, will be presenting an overview of the funded work. The project title is A Rigorous Validation of a Novel Host Micropeptide Panel for Ovarian Cancer Early Detection for Routinely Collected Clinical Samples. As we know, reliable methods for detecting ovarian cancer early are lacking. This project seeks a solution to this critical problem by characterizing bacterial microorganisms and human proteins found in fluid from Pap tests routinely collected in the clinic that may discriminate between women with ovarian cancer and those without. So, we look forward to hearing more about this important work. So, Dr. Jattab, thank you for joining us.
Good evening, everybody. First of all, I'd like to thank giving us this opportunity to present some of the work that we have been doing at University of Minnesota. It's indeed extremely privileged to be part of this alliance. And I'm here in place of Professor Tim Griffin. My name is Pratik Jattab. I'm a research assistant professor at University of Minnesota. And I'm going to be presenting some of our work on behalf of the team, out of which I think Kristi and Ovarian and Dennis Kovitz are already here. So we basically are working on some of the factors that affect how cells can get converted into cancer cells. So for example, it's been known that there are quite a few environmental factors as well as genetic factors which could lead an epithelial cell, and it could be an ovarian cell that could lead into a cancer cell. However, what has been slightly less appreciated is the role of microorganisms or bacteria that are present in cervical fluids that might actually affect or have an effect on the progression of these of the ovarian cancer. So there have been quite a few reports of bacteria that have some role in which affect the progression of these cancer, or might have an effect on the epithelial cells, which might lead it to go into cancer cell. Most of the research, when they research this microbiome as it's called, focuses on which are the different bacteria that seem to be affecting this, rather than what do these bacteria do. So our team is focused on actually looking at which proteins are expressed by this bacteria, so as to find out new biomarkers, as was described by the previous speaker. And for that, we use this method called as mass spectrometry method. So we basically study a method called as proteomics, wherein we are looking at proteins that are expressed by these bacteria, as well as proteins that are expressed by the host cells. So for this, we worked on some Pap test fluid samples which are readily available, and these came from Dr. Skubitz's lab. We studied 20 non-cancer controls and 20 ovarian cancer patients, and we subjected it to mass spectrometry analysis, so we could detect proteins that are expressed by these bacteria as well as by the host proteins. And then we subjected it to an elaborate advanced bioinformatics analysis, which is a term that's used basically to analyze the data that comes out of this mass spectrometry instrument. So what basically this workflow does is, it puts in, kind of casts a wide net in detecting these proteins that are expressed, and then also has some kind of a control in terms of, some kind of quality control in terms of reporting only those proteins which could be useful for further analysis. So as a result of this bioinformatic workflow, we could detect quite a few proteins that are what we call as differentially abundant, or proteins that are expressed in one condition versus another. So as I mentioned before, here we were studying ovarian cancer samples as well as control samples. And so what you see here are the dots that you see in orange or blue are proteins that are present in one sample versus another. And so these are basically candidates for novel biomarkers, or basically proteins that could be used for screening
for treatment or possibly for some kind of a diagnosis that can be done. So we found quite a few of these proteins, both microbial proteins, as you can see in the top panel, as well as human proteins in the various samples that we compared. One of the findings that we had as a result of this earlier finding that we had was that microbial peptides that we detected, the microbial proteins or peptides that we detected, actually helped us to discriminate between ovarian cancer patients versus control. So we believe that microbial peptides, along with the human peptides that we detect, might actually have a potential in detecting ovarian cancer early in the ovarian cancer stage. So with this basically led us to, we applied for a new grant proposal, and based on these earlier results, and what we have now, or what we plan to do is, we want to verify these promising biomarkers that we have detected in a slightly more number of samples, so an expanded data set. We also want to validate them using a method called as targeted proteomics analysis. So we want to basically look at multiple samples and try to find out whether these biomarkers are actually changing in various samples so as to validate them, so that we can use it for clinical research. And then we also want to evaluate the performance of these validated biomarkers so that one can use them for early detection of cancer. We hope by doing this, we should be able to detect more biomarkers, and hopefully this will help in liking the way as is the theme of this alliance of this annual meeting, and hopefully can help in early detection of ovarian cancer. Thank you.
Hello, my name is JC Inger. I'm probably a new face to many of you who've been with MOCA for several years now, but maybe like some of you here in this room, I have had a loved one who had ovarian cancer. My grandmother passed away from ovarian cancer in 2006, and for nearly the past 10 to 15 years, now my family has been involved with MOCA in many ways, from volunteering and even serving on the board of MOCA. I've been lucky enough to extend my involvement with MOCA now to being a consumer reviewer, and started helping with this last fall. I currently work as a pediatric genetic counselor at Health Fairview, but had lots of training in cancer genetics and genetic counseling, and even participated in some molecular biology research many years ago. So it's my pleasure this evening to get to announce one of MOCA's grant recipients this year. Dr. Arun Kanakantharna is an assistant professor in the Division of Oncology Research with a joint appointment in the Department of Molecular Pharmacology and Experimental Therapeutics at Mayo Clinic. Dr. Kantharna's research interests lie in ovarian cancer and understanding how these cancers become resistant to therapies. His lab is now focusing on exploring the metabolic changes and altered DNA repair mechanisms in ovarian cancer cells, with a specific emphasis on identifying therapeutic vulnerabilities. Dr. Kanakantharna's proposal, titled A Novel Therapy for High-Grade Serous Ovarian Cancer, aims to study the effects of a compound called KPT-9274 as a possible combination therapy with PARP inhibitors to prevent or delay the onset of PARP inhibitor resistance in ovarian cancer, which we all know is a challenge when it comes to ovarian cancer treatment. And to tell us a little bit more, please welcome Dr. Kanakantharna.
Thank you, Casey. The instruction from Jody was that I prepared like 3-4 slides for this presentation, but I was very obedient. I prepared 4 slides, and it will be a very non-scientific presentation. But this is the first time I tried the MOCA award, and I was so lucky to get it. And so I'm deeply honored and humbled to stand before you as a recipient of this award. As an ovarian cancer researcher, this funding is very special to me because, as you all know, this is from an organization which has been in the forefront of raising awareness and funding important research initiatives in the fight against ovarian cancer. So to be recognized by such an organization, dedicated organization, is a great privilege beyond words. So thank you, MOCA. Thanks to each member of MOCA, from the board members to staff, volunteers, survivors, advocates, adversaries, and most importantly, the donors whose generous support drives our collective mission to find a cure for ovarian cancer. And at this moment, I also would like to thank my mentors, collaborators, and my family who have joined here, my wife and 2 little girls, for supporting me throughout my career. And a big thanks also goes to these people. This is my team. They have also joined me here tonight. As you can see, I have a very happy group of people most of the time. But no, just kidding. You know, they are the heroes and the backbone of my research lab, and they are the one fueling the engine of discovery and progress. And the credit of output actually also goes to them. So with this, I have also put together 2 slides just to give you a very brief overview of what we are planning to do with this award. So the main goal of my lab is to develop a new effective therapies for ovarian cancer, especially high-grade serous ovarian cancer. And with that, currently we are targeting the key energy sources of ovarian cancer cells. And we believe that blocking the energy supplies which help ovarian cancer cells survive is one of the best ways to selectively kill ovarian cancer cells without significantly affecting the normal cells in our body. In that effort, we identified a drug which we named KPT-9274, but I put drug A here. And because we had an ongoing confidentiality agreement with the company, so I was not supposed to reveal the actual name of the drug here, but that's okay. So what we found is in preclinical models of ovarian cancers, this drug is very effective in reducing the tumor, especially when we combine it with one of the standard of care therapies for ovarian cancer called PARP inhibitors. So how we found out that is in collaboration with one of the physician scientists in Mayo, Dr. John Varoha, we took ovarian tumors from patients and implanted that in mice. And then some mice we treated with this drug combination, and some mice we left untreated. And in the treatment group, the outcome was super exciting. And this was an example for it. Since we don't have the mice, I can use this show here. So this shows the tumor area or tumor growth. So if the line is going up, that means the tumor grew. And if the line touches the bottom black line corresponding to 0, that means there is no detectable tumors. And I want your special attention on that red line at the very bottom. That represents the drug A and PARP inhibitor combination. And the black line is untreated one. As you can see here, the line is going up. That means the tumor grew, and then once it reached at the top, there is no line. So that means the mice died because of tumor burden. But when we look at the red line, where we treated the mice with drug A and PARP inhibitor, that touched the 0. That means no detectable tumor within 4 weeks. But we didn't stop the treatment. We continued the treatment till 9 weeks, just to make sure we eliminate as much tumor cells as possible. And then after that treatment, after that 9 weeks, we stopped the treatment and we just monitored the mice just to see if the tumor ever comes back. And we monitored the mice for 14 weeks, and still there were no detectable tumors. So that was very impressive, and that made me sleepless for a few nights in a good way, because we have never seen such an effect with any drug before. And this is something we should actually take to the clinic. But before we pull the trigger, we want to do some more study just to develop a compelling rationale for why and how we should take the drug to the clinic. And that is what we are planning to do with this MOCA funding. So we will first study what's the mechanism of action of this drug. and then we will identify the potential biomarkers of response to that drug. And that is very important to select the right patient who are most likely to benefit from this combination therapy. So as you can summarize from this slide, MOCA is playing a key role in taking our preclinical findings into a potential clinical trial. And as I mentioned earlier, I have a very hardworking team, and we are very confident that we should be able to make that happen. So with that, I would like to thank MOCA again for supporting us, and I also would like to congratulate all other recipients of this award, and I'm sure together we are making a difference. Thank you.
Thank you to all of our award recipients. We have one more to go. I do want to say that Lieutenant Gandhar, this is his first award, as he said, from MOCA, and he's of all the awardees, he's the only one with a first-time grantee. So our other awardees have all received past support from MOCA to build on their work. We love bringing new people into the fold too. So it's my pleasure to introduce our fifth and final award. This goes to Dr. Matt Block. It's very exciting. It's a phase 1/2 clinical trial testing the combination of folate receptor alpha dendritic cell vaccine with the immune checkpoint inhibitor pembrolizumab in patients with recurrent ovarian cancer. Now, this project is particularly exciting for MOCA for several reasons. First of all, Dr. Block is a clinician researcher. Many of you know him as your doctor. He directs chemotherapy for patients, including many MOCA members. He truly gets this disease and its impact on people, not just mice. Mice, we appreciate all of our researchers, though. We like that you get to meet people with ovarian cancer. Secondly, MOCA has invested in the development of this approach starting back in 2014. So it's especially gratifying to be able to support this new trial that is available to women living with recurrent ovarian cancer today. We started in 2014, that's 10 years ago. We always want this to go faster, but we appreciate the persistence and rigor of these researchers. So please join me in welcoming Dr. Matthew Block, Associate Professor of Oncology.
Well, thank you so much, Kathleen, and good evening. As was said, I'm Matt Block, and I treat patients with ovarian cancer as a medical oncologist, and I also conduct cancer research. Thank you for coming this evening, and thank you also so much for your support of our work, and specifically, I'll talk today about a vaccine clinical trial where we're combining a dendritic cell vaccine with an immunotherapy drug called pembrolizumab for patients with recurrent ovarian cancer. So one of my major career goals has been to better understand how vaccines and other forms of immunotherapy can impact ovarian cancer. We've known for a long time that cells from the immune system often will infiltrate into ovarian tumors, and you can see these cells shown in the brown in this microscopy photo. But unfortunately, most of the time, the immune cells fail to prevent the tumors from growing. What we've more recently learned is that there are multiple qualitative differences in the types of immune responses that can be generated, and not all immune responses are equal in terms of their effectiveness. In particular, we have found that ovarian cancer patients who mount what is known as a Th17 immune response, an immune response in which the protein IL-17 is produced, have a much better prognosis than patients who do not mount this type of an immune response. And so based on this, we hypothesized that a vaccine that drives a Th17 immune response might better control ovarian cancer. And so, as Kathleen mentioned, with crucial support from MOCA 10 years ago, we set out to test this in patients in a phase 1 clinical trial. We evaluated patients on this trial who had advanced ovarian cancer, stage 3C or stage 4, and were in remission after their initial operation and course of chemotherapy. To build the vaccine, we took white blood cells from patients via a process known as apheresis, and then we cultured those white blood cells in a cell therapy laboratory to produce immune-stimulating cells called dendritic cells. We could then confirm the quality of the dendritic cell product and then deliver it back to patients as a vaccine. And when we analyzed this clinical trial, we were very pleased to find that the vaccine was very safe, but also that we saw IL-17 producing, or Th17 immune responses in the vast majority of the patients whom we vaccinated. And these immune responses recognized protein from ovarian cancer. Importantly, we also saw that about 40% of the patients whom we treated on this clinical trial with stage 3C or stage 4 ovarian cancer achieved a durable remission of at least 5 years. And many of these patients are alive and in remission yet today, 8 to 10 years after enrolling on the study. We compare that with a contemporary cohort of patients with the same stage of disease, treated in the same fashion except without the vaccine, and we see far fewer long-term remissions. So we were and are very excited about these results, but we always want to improve and look to ways that we can make the treatment better. And so one of the things that we did is we looked at recurrent tumors in those patients who experienced recurrence despite receiving the vaccine. And we saw a common theme. All of the tumors we examined had high levels of the same immune evasion protein known as PD-L1. And this protein, happily, is now targeted by multiple clinically approved immunotherapies, including the drug pembrolizumab. And so now, with renewed support from MOCA, we are able to activate and initiate a clinical trial, both a phase 1 trial to test the safety of this combination and a phase 2 trial to test whether it is effective in patients with recurrent ovarian cancer. And here you can see the study timeline where we're giving both vaccine and the immunotherapy drug every 3 to 6 weeks. Again, as was mentioned, a clinical trial does not happen when a physician or a scientist says, hey, I want to do this, I have this great idea. It happens only when there are patients who are willing to step out into the unknown and test something and try something new. It only happens when there is a huge team of not only physicians and scientists, but also nurses, allied health staff, and in some cases, manufacturing experts who are dedicated to a common goal. And it only happens with substantial financial support. And I thank you so much to you, MOCA, for your support of this study and making it possible. So thank you.
Wow. Thank you, Dr. Black. As a survivor, I'm super excited about all of this. So let's give all of our research award recipients another round of applause. We're inspired by your projects, and we can't wait to hear about the progress over the next year.